Hello, kicking off the 2023 maths. If you find these videos useful, please hit the subscribe button. In this video, I'm going to go through the multiple choice questions at the beginning of the paper, starting with A. In this question, we've got alpha is log 2, beta is log 3, gamma is log 7. Each of the following numbers is close to an integer. Which is closest to an integer? Right, they've given us a hint of 2 to the 2 times 3 to the 5. Okay, so 12 times 81 is 972. Right, that's a bit of a strange thing to call a hint. Not that hard to work out, really. But right, well, let's go through each one of these. They're all log base 10, so we just want to see which one is a number closest to a power of 10. 2 beta, so 3 squared, that gives us a 9. 5 alpha plus beta, so 5 alpha is 64, and then times 3 gives us 192. That doesn't look very good at all. Alpha and 2 gamma, so 2 times 49, 98. Right, that's winning so far. 2 alpha plus 5 beta, so that's the one they've given us in this hint, 972. And then 2 alpha, so 4 times 3 times 7, so 4 lots of 21, 84, which isn't even close. So it's going to be the 98 being closest to a power of 10. So C. B. Exactly one of these 5 numbers is a square number. Which one? Right, so they're all not, no, they're not all 9-digit numbers. The first one's an 8-digit number, but it's one short of a 9-digit number. One short of 10 to the 8. And 10 to the 8 is a square, so that ain't going to be a square. Square numbers don't end in 3. So we've got these ones left. I reckon it's going to be either C or D because they both end in 5. So if they end in 5, then it needs to be a number that ends in 5 that's being squared. So it's got to end in a multiple of 25. So it's not D. It could be C, and that's where my money's going on this. And then for E, we've got 3 zeros at the end. Well, that isn't going to work because if it ends in 0, then it needs to be a multiple of 10 that we're squaring. So we've got 10x times 10x. So you get a double 0 on that. But we could get rid of those 2 zeros at the end and then still say it's x squared, which means we'd need a double 0 again, and we've only got 1 0. So it's not going to be E. It's going to have to be C. Right, so we started with a couple of C's. Then question C. I've seen this picture before. They've had this in the physics paper going back about 20 years ago. So I wonder if they ask the same question. Are they repeating themselves? 2 circles inside a square ABCD of side length 1. One of the circles is tangent to sides ABBC. The other one is, everything's tangent to everything else. The area of the larger circle is 10 times the area of the smaller circle. Diagram is not to scale. What is the sum of the radii of the circles? Right, this is pretty much the same question. So we want to trace a path from one side to the other because we know that we've got a distance there, and we turn that bit into a triangle. So we've got an R, big R and a little r at these ends, and then we've got this triangle with hypotenuse of the 2 radii. So we're saying we've got R plus R plus R times sine 45 degrees, because of the symmetry is 45 degrees, is equal to 1. So that is R plus R, just factorising, 1 plus root 2 over 2. So we can make that a 2 and put everything over there, equal 1. And we want the sum of the radii, so we want R plus R. And that then is going to be 2 over 2 plus root 2. So multiply by 2 minus root 2, top and bottom, just to rationalise, which would give us a 4 minus 2 on the bottom. So that, and that all cancel, giving us B. So yeah, similar enough to what they had in a physics paper quite a while ago. D. How many distinct real solutions X are there to the equation this? All these nested squares. I suppose we just got to work from outside inwards and see what we get. So we take a square root, we're going to get plus 2 minus 2. Then we're going to add 3, which will give us 5 or 1. Then we're going to square root. So we've got plus or minus root 5 and plus or minus 1. Then we're going to add 2. So we've now got 2 plus or minus root 5, or we've got 3 or a 1. So that gets rid of that. Then we're going to root again. So, well, we're not going to square root 2 minus root 5. So we've got the square root of 2 plus root 5, and that's plus or minus. And then we've got plus or minus root 3 and plus or minus 1. That's that. Then we add on 1. That's those. And then we got, so that becomes a 2 or a 0. And then we square root again. So that leaves us with 0. That leaves us with plus or minus root 2. This one's only got one solution when we, no, well, 2 solutions. We can't have that one in there. So we've got plus or minus the square root of 1 plus root 3. And then we've got this one, which again is going to give us 2 solutions because we can't have that one when we square root. So we're going to have 7 solutions, which is C. Okay, right, this is going along swimmingly at the moment. Then we got E. The first few positive whole numbers that are not powers of 3 are 2, 4, 5, 6, 7, 8, 10. Right, so yeah, no 1, 3 or 9. What is the sum of all the positive whole numbers that are less than 3 to the 10 and also not powers of 3, less than 3 to the 10? Right, what is the sum of all the positive whole numbers that are less than 3 to the 10 and also not powers of 3? Right, so we've got an arithmetic sequence and then we take away a geometric sequence. So our arithmetic, if I can say it, sequence, well, we can go up to 3 to the 10 and then include that in what we're taking away. I mean, it doesn't really matter which way around we do it, whether you want to include it or not. But let's just go that way rather than having anything daft. Having to take the last one off is a bit of a pain, isn't it? So I'll include it in both sequences. So we've got our first term plus our last term averaged multiplied by the number of terms. So that's our arithmetic. Now we have to take off the what's going to be 11 terms in the geometric sequence because we are starting from 1. So we've got first term 1, then we got 3 to the 11 minus 1 divided by 3 minus 1 is 2. So which one of these is going to be the thing that we're looking at? So we've got a half. We've got 3 to the 20 plus 3 to the 10 minus 3 to the 11 plus 1. One of those. So it's not going to be D or E because I haven't got the half in. So it's got to be one of these ones. Now I've got to combine these middle terms in some way. So factorise 3 to the 10. Out of this 3 to the 10, 1 minus 3. So it's minus 2, 3 to the 10, plus 1, 3 to the 20. So that's 3 to the 10 minus 1 all squared. So A. Okay, it's quite a nice question. Then we got F. The coefficient of x to the 12 in that is what? Geez. Right, can I just perm this one? Well, we've got an x squared in the middle. So that could be a 10, an 8, a 6, a 4, a 2 for the powers. Could it be a 0? No, it can't be a 0 because we can't get enough from the others. No, this isn't going to work with just perming things because we've got too many options. Even for the, if we were taking x to the 10 from the middle bracket, we've still got, it could be 1, 1, 0, 2 or 2, 0 from the other brackets for the powers of x. So I don't fancy my chances of just perming this. So I think I'm going to have to combine these brackets and then say it's all to the power of 5. So 1 minus 2x times 1 plus 2x is 1 minus 4x squared. Then multiply by 1 plus 4x squared is going to get 1 minus 16x to the 4. So we've got that to the power of 5. And we want to get 12. So we need 3 of these. So if we're doing 3 out of those 5 brackets, that's going to be our 10 in our Pascal's triangle, and it's going to be the 1, 5, 10, 10, 5, 1 row. So we got a 10, and we got 3 of these. So that's going to be multiplied by minus 16 cubed. So that is 2 to the 12 times 10, and it's negative. So minus 2 to the 12 times 10. So not that one, that one, that one. And it's not that one because that's half of it. Oh yeah, they pulled one of the 2's out into there, made that 10 of 5 and just bumped the power up. So A. Okay, this is all just breezing along thus far. G, the real numbers A, B, and C are non-zero. Each of the following quadratic equations has a repeated real root, not necessarily the same value. How many distinct real roots does that one have? So if we've got repeated roots, our discriminant's going to be 0. So we've got b squared minus 4ac is 0. We've got c squared minus 4ab is 0. And we want to know about a squared minus 4bc is what? Right, so what am I doing with these equations? Right, I want to cancel these second terms. So I need to multiply the top one by b and the bottom one by c. And then we can cancel those and say that b cubed is equal to c cubed. So b is equal to c, which would be equal to 4a. Right, okay, so we just drop it into here. We've got a squared minus 4 times 4a squared, which is equal to a squared minus 64a squared. So that's definitely less than 0. So we've got no distinct real roots. A. H, which of these triangles has the largest area? We've got 5 isosceles triangles with those side lengths. They've all got a 10, 10 on them. So we've got a 10, we've got a 10, we've got change in length here, which is 1, 5, 10, 15, or 19. Which one is largest? So we can do our half AB sine C on this. That's our C. We want to get that then. We want to get C as close as possible to 90 degrees is what we want. So how are we going to deal with that? So close as possible to 90 degrees. So we could say then, well, do I look at this with Pythagoras? Or actually, I was thinking of maybe doing a Pythagoras, which is pointing towards 15, because if we got, yeah, I mean 10 squared plus 10 squared is equal to 200. Closest we got to squaring one of these other sides is 15, giving us 225. That's too big, that's too small. So it is going to be the 15 one. Yeah, you could drop that down, I suppose, and say, well, 7.5 we'd have there. 7.5 over 10 is the closest thing to root 2 over 2. If you've got 45 degrees, doesn't really matter which way you do it. We've got D either way. I, only 2 to go. Polynomial P of x has degree 3. P of 0 is 0, P of 1 is 1, P of 2 is 2. Polynomial's got a repeated root, x equals m, with m greater than 0. What is the value of m? So let's say P of x is, this is going to be one of these deduction ones, ax cubed plus bx squared plus cx plus d. P of 0 equals 0. So we've got d is 0. P of 1 is equal to 1, which is equal to a plus b plus c. P of 2 is equal to 2, which is equal to, what have we got here? 8a plus 4b plus 2c. So that gives us that 4a plus 2b plus c is equal to 1. So these two are telling us then that 3a plus b is equal to 0. Okay, haven't done anything with m, but we'd know if it's got a repeated root there, that's going to be equal to 0. So am cubed plus bm squared plus cm, I mean d is 0, so we can ignore that. But we can cancel a whole load of m's. So we've got that as well. Let's just write that out afresh. So am squared plus bm plus c is equal to 0. We can also go for p dash of m is going to be equal to 0. So that is 3am squared plus 2bm plus c is equal to 0. So 3am squared plus 2bm plus c is equal to 0. Okay, so well, I can do some subtracting off of these then. So 2am squared plus bm is equal to 0. Cancel more m's. 2am. Oh, I got that B is minus 3A. 2AM plus minus 3A is 0. Cancel some A's. M is 3/2. E. Okay, it was long-winded, but fairly straightforward bit of algebra, pulling all that together. We're already on the last question. So J, let X in those weird brackets denote the largest whole number that's less than or equal to X. For example, minus pi in those brackets is -4. Yeah, we're just dropping it down to the lowest, the next whole number that's below it. Function f of x is defined as follows. If x is between 0 and 2, then we got that, otherwise it's 0. Note that, for example, f of a half is 4/3. So that would be log base 2 of a half is -1. The brackets don't change to -1, so we do the reciprocal of 3/4 to get 4/3. Fine. So what is this integral? Right, let's get a handle on the exponent, I think. So x, and what is that leaving for the exponent? So let's look at the easy values if we're in log base 2. So we go 2, 1, a half, a quarter, an eighth, and so on. So if it's 2, we get 1. If it's 1, we get 0. If it's half, we get -1, we get -2, -3. So that's just a description of how logs work. If we're between 1 and 2 for x, then we're going to pick up the value below. So we're going to go down to here, and our f of x in this case, so we don't care about this first one, this 3/4, that's never going to come into it. We just don't care about that at all. From the point of view of doing this integral, it's going to be a 1 that we're picking up between x's 1 and 2. Right. Then we get our 4/3. That was the one that they were talking about. Then this one will get 16/9. So we're going up in these multiples here of 4/3. Okay, so let's try and get this onto a graph then. So we've got 1, we've got 2. That is just going flat at 1. Then we go up to here, which is 4/3, and that is down to a half. And then we've got a quarter going up here to 16/9, and so on. So that is 1 as an area, 1 times 1. This is a half times 4/3, so 2/3. This is going to be a quarter times 16/9, so 4/9. Right, so we've got a multiplier of 2/3. So we need to do a sum to infinity. First term is 1 over 1 minus 2/3. So 1/3 is 3. Okay, that was quite a nice question. That was a swift set of 10. I think as opening sets of multiple choice questions go, that 10 was fairly generous. I mean, again, none of them are going to be trivial, but overall, I don't think that was a bad bunch. Really, it'd be interesting to see how the rest of the paper shapes up. But that was a nice batch.